The construction methods of railways significantly impact performance, maintenance, and life cycle cost, with variations coming in materials, formation depths, and other factors. Slab track is a wholly different approach in its nature to the traditional railway construction. But what is slab track? Slab track, also known as ballastless track, is a railway track construction type where the rails are mounted directly onto a concrete slab. Unlike traditional ballasted track, which rely on layers of ballast stone for support, slab tracks are laid on a solid concrete foundation. There are a number of construction methods for slab track, ranging from traditional concrete sleepers being encased in concrete, precast sections manufactured off-site and then installed at the required location, or the concrete being poured in place. So what are the common uses of slab track? Slab track is widely used in some high-speed rail lines, in metro and tram systems, and areas where high levels of track fixity is needed, such as tunnels. Fixity is a measure of the degree of movement the track can achieve. Ballasted track has low fixity, as the ballast is not rigid in its support and the track position can move due to degradation and other factors. Slab track is high fixity, as the concrete construction allows very little movement. So what are the advantages of slab track? High fixity and support. The construction of slab track means it's very stable, giving little to no movement from the track bed itself. This makes it perfect for areas where engineers are concerned about track movement. These areas can include tunnels, locations of poor geology or formation, high-speed track, or where gauging and clearance is a concern. The high levels of support for other components, particularly the rails, can also reduce wear and defects as dynamic forces are reduced. Lower maintenance. With ballast being replaced by the concrete, a major source of maintenance issues is removed. If the initial construction is completed successfully and the maintenance of pads and fastenings is carried out, twist, top and alignment faults will not be present or occur. Corrections of these faults is a common and time-consuming occurrence in ballasted track. The focus of maintenance teams is therefore solely on the rails, fastenings and other components. This low maintenance requirement makes slab track a common choice for short sections of track where high reliability is required but access for maintenance is low, such as airport rail links and tunnels. Longer lifespan. If properly maintained, slab track can have a long lifespan compared to ballasted track, given that common issues such as ballast degradation, ballast fouling and formation failure are removed. As we have already seen, high stability also reduces the wear on other components. This therefore increases their asset life. In some respects, slab track is more resistant to the effects of the environment. This is especially true of water, a particular problem for ballasted track. So, what are the disadvantages of slab track? Although slab track definitely has some huge advantages, it does have some drawbacks. Higher cost. First and foremost amongst these drawbacks is the cost of construction. The cost of the initial construction of slab track is significantly higher than that of ballasted track. There is also the time it takes to install, even if using precast sections. Limited flexibility. One of the key attributes of ballasted track is the ability to change the alignment of the track through lifting and slewing. This allows alignments to be adapted to changes such as line speed or traffic patterns. This is not possible in slab track. Changes and modifications require major works. Drainage challenges. The concrete base of the slab track does not allow water to pass through it, unlike well-maintained ballasted track. This means that drainage design and maintenance is crucial to avoid water pooling and accumulating on the track. This pooling can cause issues with corrosion of the rails and other components, but also affect signalling equipment such as track circuits. So, in summary, slab track has significant advantages over conventional ballasted track that makes it suitable for some applications such as high-speed lines or where high levels of track fixity is required. It also has lower maintenance costs. However, this does come with a bigger price tag for the initial installation and lower flexibility once it's installed. I hope you found this video useful. If you want to know more about railway engineering, a great place to start is with our Track Components Guide ebook that is available at the link in the description below. If you want a little added extra, by signing up to our email list below, you'll get our free Guide to Cant ebook straight into your email inbox. Do drop any comments or queries below, hit that like button and subscribe so you don't miss a single video. Thank you.